In this question, we need to figure out the conic represented by this equation. Okay, so this is a second degree equation, right? Because xy term is there. This particular term says that this equation is a second degree equation. To identify the conic, whether it is an ellipse, parabola, hyperbola, or a pair of straight line, we need to get the value of delta. Now, what is delta? Once we know the value of a, b, c, f, g, h, we will get the value of delta. What is a, b, c, f, g, h? For f, g, h, a, b, c, we need to know the general second degree equation. Now, what is all this? So, first of all, this is a second degree equation, right? Now, we need to compare this with our general second degree equation, which looks like this. Yes, ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equals to 0 is general second degree equation that you need to learn by heart, okay? Once you learn this by heart, you need to compare the coefficients. If I see that ax square is there, now with which term I'll compare with? In this particular equation, there is no term related to x square. This means that a is 0. Similarly, b is also 0 because y square term doesn't exist in this equation, our equation, right? So, a 0, b 0, then 2hxy. Okay, 2hxy can be comparable with 2xy. This gives me h equals to what? 1, right? Similarly, 4x and 2gx, if I compare, I'll get what? G is equals to 2, f equals to minus 3 similarly, and yes, last constant term is 17. So, a, b, c, g, f, h looks like this, right? Okay. Once I got the value of a, b, c and all the coefficients, I need to calculate the value of delta. Now, what is delta? Delta is this, that you need to learn by heart. ABC plus 2FGH minus AF square minus BG square minus CH square. That's it. We need to just figure out whether it is a 0 or non-zero. That's it. I'm not interested in the value of delta actually. So, delta would be ABC. Okay, ABC. So, A and B both are 0. So, first term will be gone. Okay, 2FGH. So, 2. F is what? Minus 3. G is what? 2. H is what? 1. Right? This is 2FGH. And yes, minus AF square. Okay, so A is 0, this will be gone. B is 0, this will also be gone. And CH square, so minus 17 and 1 square. This is equal to what? 3 to the 6, 6 to the 12, minus 17, that is equal to minus 29. Okay, so the value of delta, if we calculate, it comes out as minus 29, which is non-zero quantity. When delta is non-zero, we always remember that either it is a circle or a parabola or ellipse or hyperbola depending upon A, B and H. Yes, A, B and H. So here for circle, H equals to 0, but I can clearly see that H is non-zero, right? By H, what do I mean? I don't want to see in case of circle any term related to XY. XY should be non-existent if that particular thing is a circle. That means this is not a circle first of all. Now to understand whether it is a parabola, ellipse or hyperbola, we need to calculate the value of h square and AB. We need to compare these two values. So h square is what? Tell me. 1 square. AB is what? Okay, 0. So this time h square is greater than AB, right? Which is a clear-cut case of hyperbola. So finally, this particular question says that the given curve represents a hyperbola, which means that option D is absolutely correct option. Got it? In this particular question, it is given that there are two concentric circles whose equation is given by this. Okay, so there is one equation, but this represents two concentric circles. That means the value of lambda will get changed, the constant term will get changed, then there will be two circles, right? So the value of lambda would be exactly 2. Okay. If a chord of first circle is tangent to the second circle, and the normal to another circle passing through the center of this circle and having a center at 2, minus 1 is also touching first circle. Okay, too many things. Then we are interested in actually the length of chord with respect to first circle. Okay, so very first thing is to plot the diagram. In this particular question, the moment you draw the diagram, trust me, 80% of the question will be solved. Yes. So we just need to understand and visualize, sketch the figure one by one. So two concentric circles would be there whose center would be what, that we need to figure out. Okay. So this is the equation of two concentric circle. So actually the center of the circle 1, let's mark the circles. There would be two circles, two concentric circles, circle 1 and circle 2, and the moment you need to calculate the center of those two circles would be same, right? That is nothing but minus g comma minus f. So here if I talk about the equation of circle, that is x square plus y square plus 2gx plus 2fy plus c equals to 0, right? By looking at this, we can say that g equals to what? G equals to minus 1, right? So minus g would be 1, and similarly f would be what? 2. So minus f would be minus 2. So 1 comma minus 2 is the center of circle 1 and circle 2. Both are concentric circles. Okay. And okay, in fact, the chord of first circle would be tangent to another circle. Right, so let us say this is the chord of first circle, circle 1. Let's plot the circle number 1, right? It will look like this, and this would be chord AB, right? And the center of this particular circle would be nothing but 1 comma minus 2, right? And there would be another circle with the same center, right? And it will look like this, just like this. Now what is this? Basically, AB seems to be chord of circle 1 as per the question. And this AB is nothing but tangent of circle number 2. This is what we have got the information from the question. Now we have another statement given in the question which says that this particular line is nothing but normal to the circle number 3. Yes, that means this line will pass through the center of the third circle. Whenever you see a normal of a circle, then you realize that that particular normal will pass through the center of that circle. That means we have another circle, circle number 3, and this being AB being normal to that circle. So center, already given in the question, center of that particular circle is 2 comma minus 1, which is lying on this particular line AB. Okay, so this AB is chord of circle 1, sorted. This AB is tangent of circle number 2, and this AB is normal of circle number 3 such that this circle number 3 touches the circle number 1 over here, right? Okay. So basically what we need to find out is the chord, the length of the chord. That means we need to find out the length of AB with respect to circle number 1. Okay. So the moment I see this is the center of the first circle, right? Now this is the chord of first circle. Let's visualize like this. This is the center of the first circle, and so this, let's mark this as C1, and this is chord of the first circle. Cool. If I drop a perpendicular from the center to the chord, that would be perpendicular, right? This line would be perpendicular to AB, okay? And this, if I join this is 90 degree, right? Now distance between this C1 and C3 we can easily calculate. C1 is the center of first circle, C3 is the center of another circle. So we just need to apply the distance formula to get C1, C3. So 1 comma minus 2 and 2 comma minus 1. If I apply distance formula, what do I get? 2 minus 1 whole square plus minus 1 minus minus 2 whole square. So that means square root of 2. So this distance is nothing but square root of 2. Okay, sorted. This distance is square root of 2. Now this distance AC1 is nothing but radius of circle 1. Do you realize this? Okay. And of course, one more thing. If I know this distance C1, C3, that is root 2, which is radius of circle number 3, then this is also radius of circle number 3, right? And this would also be root 2. So the overall distance, this distance I am talking about C1, and let's mark it as any other point, C1x. C1x is nothing but 2 root 2. Do you realize this? And in fact, the C1 is the center of circle and x is the point on circumference of the circle. Right, I am talking about circle number 1. So this distance C1x is nothing but the radius of circle number 1, which is 2 root 2, right? So the radius of circle number 1, which is AC1, which is nothing but 2 root 2, because these two distances AC1 and C1x are one and same thing, representing radius of circle number 1. Now you have this distance, you have this distance. Okay, let me change the color. You have this distance, you have this distance. Now by applying Pythagoras theorem, can you calculate this distance? Right? And once you double that distance, what will you get? AB, which is the chord of circle number 1, which we are looking for, because obviously this perpendicular bisects the chord. Right? So this AC3 and C3B are equal. So we just need to apply Pythagoras theorem in that. Okay, so if I apply Pythagoras theorem, what do I get? 2 root 2 square minus root 2 square whole square root is nothing but what? AC3. Pythagoras theorem. Hypotenuse square minus perpendicular square whole square root would be equals to base, just like this. Now this will be what? 8 minus 2, that is equals to 6. So square root of 6 would be AC3, and if I double this quantity, what do I get? The length of AB, which is equals to what? 2 root 6. So final answer of this particular question is nothing but 2 root 6. So now you see that there are few questions which involves visualization and the diagram making, the diagram sketching. Once you sketch the diagram, once you do the constructions, the problem is very easy. You just need to interpret the geometrical conditions, apply the simple Pythagoras theorem and simple basic things which you are knowing since class 10th. Right? By using those concepts, you can find the answer. Got it? In this question, we need to figure out the locus of a point whose sum of the distances from the origin and the line x equals to 2 is 4 units, and the option given are in front of you. So the moment I read, I need to determine the locus of any point. What is the first thing that comes up in our mind? The very first thing is, let us say that the coordinates of that particular point is h comma k. Yes? Let me draw the rough sketch of this particular situation. So we have a point, let's say this point is P, h comma k, right? Now as per the question, locus of a point whose sum of the distances from the origin and the line x equals to 2 is 4 units. So over here, this particular point P, the distance of this point from origin would be like this, OP. Right? And we have another line. That line is nothing but x equals to 2, right? So this is line x equals to 2. And the distance of this particular line from point P, let's say this would be this particular distance, right? So sum of these two distances is given as nothing but 4 units, isn't it? Sum of these two distances is equals to 4 units. This is the particular situation. Now let's draw this particular diagram very nicely over here. So we have, yes, point P, h comma k, and we have this origin, OP is this, and this is the perpendicular distance. Let's mark it as m, right? And this line is x minus 2 equals to 0. Now, distance of any point from the origin we can easily calculate by distance formula, right? And that would be nothing but square root of h minus 0 square plus k minus 0 square, right? So distance of the point from the origin is this, which is nothing but square root of h square plus k square, just like this, right? This is OP. Now we need to calculate PM, right? And PM, actually, if I am able to see PM, now this is pure common sense. This PM distance we need to calculate, okay? So what I can clearly see over here is this distance is 2 units, isn't it? This distance is 2 units. And by the way, whenever the term distance is used and no more information about the distance is given, that means we are only trying to find out perpendicular distance, right? So that's why this is 90 degree. And this distance is 2 units, right? Since this point is h, this point is like x coordinate of this particular point is h. So this distance would be h, right? H units. And we are actually interested in this PM. PM would be nothing but modulus of 2 minus h, right? Or h minus 2, whatever is the positive value, because we are calculating distance, right? So h minus 2 or 2 minus h, subtraction of these two. So As we can see over here in this particular diagram, because P is moving point, we don't know H is greater than 2 or less than 2. So as we can see over here is 2 seems to be greater than H, but this is not always true, because P is moving point. P can be over here as well, right? And we are looking for what? Locus of this particular point P. Okay, so PM would be equal to modulus H minus 2 or 2 minus H, one and same thing. So distance of point from this particular line would be nothing but modulus H minus 2. Now this is nothing but OP, this is nothing but PM, and OP plus PM would be 4 units as per the question. Let's add these two. If I add these two, what do I get? I get H square plus K square square root plus modulus H minus 2 is equals to 4, right? And if we actually solve this, what do I get? H square plus K square is equals to 6 minus H if I assume that H minus 2 is greater than 0, right? So here if H minus 2 is greater than 0, then this is the scenario. Now we need to actually square both the sides, right? If I square both the sides, what do I get? H square plus K square on the left hand side, and on the right hand side 6 minus H whole square, right? So that would be H square plus K square is equals to 6 minus H whole square would be what? 36 plus H square minus 12H, right? And now H square gone, cool. And now I am left with K square is equals to, now I need to take minus 12 common from this. If minus 12 is common, then okay, H minus 3 would be there. And if I replace K by Y and H by X, what do I get? I actually get Y square is equals to minus 12X minus 3. Now what is this? We need to figure out. What is this? So this is nothing but a parabola, because this is of the form y square is equals to some constant, 4a is the constant, and x, right? Y square is equals to 4x. This is of the form, so this is the parabola. Now we just need to check whether this is there in our options or not, because this is single correct option, right? Single correct option type question. So if this matches, then it's okay. If not, then we need to check for the modulus condition, which can open in a negative sign, right? So let us check. Okay, I can clearly see that this option is matching, which is option A. Y square is equals to minus 12 x minus 3, which is a parabola. But then in this particular question, we don't need to know that what form is a parabola. But additional information, if you see y square is equals to some constant and linear bracket of x, another variable, then this is a parabola. Got it? In this particular question, we need to figure out the locus of the center of a circle passing through a point and touching a line. Here, this point is a fixed point and this line is a fixed line. Okay, a fixed point and a fixed line is involved. And over here, we need to understand whether it is a straight line or an ellipse, a parabola or a hyperbola. So let us understand this particular situation with the help of visualization. So this is the line, any line ax plus by plus c equals to 0. I'm not interested in the equation of the straight line, but we do have a fixed line, okay. So this circle is passing through, actually this particular circle is touching this particular fixed line, okay. So the figure will somewhat look like this. This is the variable circle, right? There will be multiple circle which would be what? Touching this particular straight line. Right? Multiple figures would be there. Multiple circles would be there. Okay. But the very important thing is all the circles, all the variable circle passes through a fixed point. Okay. So passes through a fixed point. That means let's say that fixed point is alpha comma beta. Now we need to draw the circles. We need to keep that in mind that all the circle will pass through this particular point and touch our very own line. Just like this. Okay. This is the center of this particular circle. This is the line. What I can clearly see that we are actually interested in the locus of the center. So let's mark this as P, right? H comma K. Now if I carefully observe that this distance is what? Radius of the circle, the variable, because circles are variable, radius will also be variable. this perpendicular distance from point P to this particular line is R. Okay, so PM would be R. Right? And actually what I can see is from point P to this point F, let's say. So PF is also radius of this particular circle, and in fact PM is always equals to PF. A variable point moves such that, listen to me carefully, a variable point moves such that the distance of this particular moving point from a fixed point F and from a fixed line L are equal. Let me repeat myself. A variable point whose distance from a fixed point and a fixed line are equal. What do we call it? We call it a parabola, right? We call it a parabola. So in this particular question, the understanding, the concept is basically of a parabola, right? So let's write everything down now nicely. Now you know the answer. Let the point is alpha comma beta. Let the line is ax plus by plus c equals to 0. This is the line. And the center of circle being x1 comma y1 or h comma k, whatever you can take. So these are the two variable circles and the point in common. All the circles will pass definitely through alpha comma beta, right? So this point is nothing but alpha comma beta, and you need to imagine that the center, there would be multiple circles. This is also one of the circles. The center will lie on this particular parabola. You need to imagine that all the circles will have center, and if you join all the centers, what do you get is a parabola, right? Because this is the moving point P, and always if you consider this point F, so PF is equals to what? PM is equals to radius of this particular circle, right? Radius will change. For every particular circle, radius will change. But basically, the ratio I'm talking about, PF by PM is equal to what? 1. This is the condition of parabola. Always, PF will be, for a particular circle, PF will be radius of that circle. PM will be the radius of that particular circle as well. So, R by R will be 1. Wherever P goes, this will remain 1. So this is the clear-cut case of option C, a parabola. In this particular question, it is given that there is an equilateral triangle which is inscribed in this parabola y square is equals to 4ax, such that one vertex of this triangle coincide with the vertex of parabola. Do you know the vertex of this parabola? This parabola has vertex 0, 0. That means 0, 0 is one of the vertex of equilateral triangle. Okay. Then we need to figure out actually the length of side of this triangle. Side of equilateral triangle we need to determine. So for that we'll sketch a rough figure. You know how y square is equals to 4x look like this. This would being focus a, 0, right? 0, 0 being vertex, and this vertex will coincide with vertex of equilateral triangle. Okay, now I need to draw a triangle in which the other two vertices also lie on this parabola. Do you realize this? And this parabola is symmetric about x-axis, right? That means our equilateral triangle, since equilateral triangle is symmetric, this parabola is symmetric, one vertex lie on origin. That means our equilateral triangle will be symmetric about x-axis, right? Our equilateral triangle will be symmetric about x-axis. If this angle is 60 degree, of course this angle is 60 degree. Every angle is 60 degree in equilateral triangle. If this angle is 60 degree, then these two angles I'm talking about would be what? 30 degree each. Yes, 30 degree each. Okay. Now let's draw the figure very nicely and understand how we are going to get the side of this equilateral triangle. This is the diagram. OAB is equilateral triangle, right? And the whole angle is 60 degree and individual two angles would be what? 30 degree. We already know vertex lies at origin. This is what we have drawn already, and triangle OAB be an equilateral triangle. Of course, angle OAB is 60 degree and two individual angles are 30 degree. Okay, let us assume that the length of side of this triangle is k. Everything is k. OA, AB, BO. Everything is k, equilateral triangle, right? So if this length is k, understand one thing. If this length is k, can you comment, and this angle is 30 degree by the way, can you comment on this particular length? I'm talking about this length. Can you comment on this length? This length actually would be nothing but k cos 30 degree. And this length would be, okay, this would be k sine 30 degree and this length would be k cos 30 degree, right? Perpendicular length would be k sine 30 degree and this would be what? K cos 30 degree, okay? If I talk about the coordinates of A would be what? The x coordinate would be what? K cos 30 degree, right? X coordinate is k cos 30 degree, which will be equal to k root 3 by 2, and y coordinate would be k sine 30 degree. You know the value of sine 30 degree, right? So k by 2. You've got the value of x coordinate, you've got the value of y coordinate of A, and this x comma y is lying on the parabola y square is equals to 4x. Now you understand what we are going to do. We are interested in the value of k. We just want one equation related to k and everything will be solved. So we just need to put the x coordinate of A in this, y coordinate of A in this to eventually get the final answer of this particular question. So k by 2 whole square would be equals to 4 multiply A multiply x, right? And x would be what? K root 3 by 2. So this 2 and this 4 will be gone. K will be cancelled out. So k will be equal to what? 4 to the 8 A root 3. Yes. Side of this equilateral triangle in terms of A we've got, which is 8A root 3, right? So final answer of this particular question is nothing but option D, 8A root 3.